Let us consider an example of selecting 2 people out of 3 people, X, Y and Z. We may select X, Y or Y and Z or X and Z. These are the 3 possible combinations. If you arrange the selected 2 persons, then we will have, see the arrangement, we can arrange as X and Y or Y and X. This can be arranged as YZ or ZY. This can be arranged as XZ or ZX. These are the possible permutations. We know that number of permutations will be more than number of combination cases. So NPR formula is n factorial by n minus r factorial, and NCR formula will be n factorial by n minus r factorial times r factorial, because r factorial permutations will be one combination. Therefore, NCR formula is n factorial divided by r factorial times n minus r factorial. Therefore, we can say that NPR is equal to NCR times r factorial. This is theorem 5. And another important result is NCR is equal to NC n minus r. This result can be easily proved just by applying the formula of NCR. See the left hand side. NCR is n factorial divided by r factorial times n minus r factorial. And RHS is NC n minus r, which is equal to n factorial divided by n minus r factorial times n minus of n minus r, which is r factorial. LHS is equal to RHS. Therefore, NCR is equal to NC n minus r. This is an important result. Let us do exercise 7.4, question number 1. If NC8 is equal to NC2, find NC2. So NC8 is equal to NC2. N and N are same, so we cannot equate 8 and 2. So I am going to use NCR is equal to NC n minus r formula. I am using this formula on the right hand side. So it becomes NC n minus 2, or we may use it on the left hand side also. Now we can equate 8 and n minus 2. Therefore, n is equal to 10. And we have to find NC2. N is 10. So NC2 is equal to, let us use NCR formula, which is n factorial divided by r factorial times n minus r factorial. 10 factorial divided by 2 factorial times 10 minus 2 is 8 factorial. Let us cancel 8 factorial. 9 times 10 divided by 2 factorial is 2. The answer is 45. Second question. Determine n if 2nc3 is 2nc3 is equal to 12 is to 1. 2nc3 is 2n factorial divided by 3 factorial multiplied by 2n minus 3 factorial divided by, the denominator formula is n factorial divided by 3 factorial times n minus 3 factorial is equal to 12 divided by 1, which is 12. Cancel 3 factorial. Let us write the reciprocal of the denominator. We get 2n factorial divided by 2n minus 3 factorial times n minus 3 factorial divided by n factorial equal to 12. If you compare 2n factorial and 2n minus 3 factorial, we can write 2n factorial as 2n into 2n minus 1 into 2n minus 2 and 2n minus 3 factorial divided by 2n minus 3 factorial. Like 8 factorial can be written as 8 times, 7 times, 6 times, 5 factorial. So like that we have written 2n factorial so that we can cancel 2n minus 3 factorial. Similarly, here the bigger number is n. If you compare n minus 3 and n, the bigger number is n. So I can write this n factorial as n times 1 lesser than that is n minus 1, lesser than that is n minus 2 times n minus 3 factorial is equal to 12. I can cancel n here. If I have 2n factorial divided by n factorial, I cannot cancel n here because we have factorials. But here I can cancel n because we have 2n divided by n without factorial sign. And here if I take 2 common, n minus 1 and n minus 1 will get cancelled, we'll get 2. So we have 4 times 2n minus 1 divided by n minus 2 is equal to 12. Cancel 4. Now cross multiply. 2n minus 1 is equal to 3n minus 6. Therefore, n is equal to 5. Look at the second subdivision. The left hand side is the same. 2nc3 is to nc3 is equal to 11 is to 1. Only that right hand side number is different. So same method let us follow. 2n factorial by 3 factorial times 2n minus 3 factorial. Let us write the reciprocal of nc3. N factorial divided by 3 factorial times n minus 3 factorial. I have written the reciprocal is equal to 11. Now 2n factorial can be written as 2n times 2n minus 1 times 2n minus 2 times 2n minus 3 factorial divided by 2n minus 3 factorial multiplied by n minus 3 factorial divided by, let us write n factorial as n times n minus 1 times n minus 2 times n minus 3 factorial equal to 11. Cancel these common factors. We can cancel n and this n minus 1 could be cancelled here. We will have 2. 2 2s are 4. 4 times 2n minus 1 divided by n minus 2 is 11. Let us cross multiply. 8n minus 4 is equal to 11n minus 22. 11n minus 8n is 3n and 22 minus 4. So 3n is 18, n is equal to 6. Question number 3. How many cards can be drawn through 21 points on a circle? So chord of a circle means line joining any 2 points of the circle. AB is a chord. BA is also the same chord. So we are not bothered about the arrangement of the letters AB or BA. Both are the same chords. So here it is not a permutation question, it is a combination question. So how many chords can be drawn through 21 points? Line joining any 2 points is known as a chord. So how many 2 points combinations are there? So number of cards is equal to 21C2. Let us use NCERT formula, which is n factorial divided by r factorial times n minus r factorial. 21 factorial divided by 2 factorial times 21 minus 2, 19 factorial. Let us cancel 19 factorial from 21 factorial. 20 times 21 divided by 2 factorial is 2. 210 cards can be drawn. Question number 4. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? 5 boys and 4 girls are there. We have to select a team of 3 boys. So out of 5 boys, you have to select 3 boys, and out of 4 girls, you have to select 3 girls. This is only a selection question, so it is a combination question. 3 boys out of 5 boys can be selected in 5C3 ways. Similarly, 3 girls out of 4 girls can be selected in 4C3 ways. Therefore, total number of ways of selection is equal to 5C3 times 4C3. Why do we multiply here? Because we need to select 3 boys as well as 3 girls, and so we need to multiply. Let us simplify this using NCERT formula. Cancel 3 factorial. 4 times 5 divided by 2 factorial is 2. And here if you cancel 3 factorial, it is 4. The answer is 40. So 40 different ways are there to select 3 boys and 3 girls out of 5 boys and 4 girls. Question number 5. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls. So totally we have 6 red balls, 5 white balls and 5 blue balls. Totally 9 balls have to be selected. If each selection consists of 3 balls of each color, so we need to select 3 red balls and 3 white balls and 3 blue balls. So total number of ways is equal to now 3 red balls out of 6 red balls can be selected in 6C3 ways, and so we need to multiply. 3 white balls out of 5 white balls can be selected in 5C3 ways, and similarly 3 blue balls out of 5 blue balls can be selected in 5C3 ways. Let us simplify. This is 6 factorial divided by 3 factorial times 3 factorial, and this is 5 factorial divided by 3 factorial times 5 minus 3 is 2 factorial, and here it is the same. Let us cancel 3 factorial. 4, 5 and 6 divided by 3 factorial. Cancel 3 factorial from 5 factorial, so we get 4 and 5 by 2 factorial is 2. 4 5s are 20, 4 5s are 20 times 5. The answer is 2000. Question number 6. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. So we know that in a pack we have 52 cards. Now in these 52 cards, how many ace cards are there? 4 ace cards are there. And remaining non-ace cards? 52 minus 4, 48. Now we are selecting 5 cards. Out of these 5 cards, exactly one ace card should be there. So we need to select one ace card and the remaining 4 cards should be selected from non-ace group. So we need one ace card and 4 non-ace cards. One ace card out of 4 ace cards can be selected in 4C1 ways. Since the question is talking about ace cards, so we have grouped the whole pack as ace and non-ace. 4 non-ace out of 48 non-ace cards can be selected in 48 C4 ways. Therefore, total number of ways is equal to, we have to multiply because we need one ace card and 4 non-ace cards. Let us simplify this. 4C1 is 4 factorial divided by 1 factorial times 3 factorial. And this is 48 factorial divided by 4 factorial times 44 factorial. Cancel 3 factorial from 4 factorial, we have 4 here. And cancel 44, 45, 46, 47 and 48 divided by 4 factorial. Let us multiply these numbers. The answer is 778320. Question number 7. In how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? Since the question is about bowlers, we will group them as bowlers and non-bowlers. So in this group of 17 people, we have 5 bowlers and the remaining 12 are non-bowlers. We are selecting a team of 11. This team must include exactly 4 bowlers. So we need to select 4 bowlers. So the remaining 11 minus 4 is 7. 7 players we have to select from this group, non-bowlers group. Total number of ways will be, we can select 4 bowlers out of 5 in 5C4 ways, only selection here, and we need to select 7 from non-bowlers group out of 12 players times 12C7. 5 factorial divided by 4 factorial times 5 minus 4 is 1 factorial multiplied by 12 factorial divided by 7 factorial, and 12 minus 7 is 5 factorial. Let us cancel 7 factorial from 12 factorial. 8, 9, 10, 11 and 12. Divided by 4 factorial is 2 times 3 times 4. 36 times 110, and the answer is 3960. Question number 8. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. So we need to select 2 black balls and 3 red balls, and we need to multiply. It is a combination question. So 2 balls out of 5 can be selected in 5C2 ways, and so multiply with 6C3. Very simple question. 5 factorial divided by 2 factorial times 5 minus 2 is 3 factorial, multiplied by 6 factorial divided by 3 factorial times 6 minus 3 is 3 factorial. Let us cancel 3 factorial from 5 factorial. 4 times 5 divided by 2 factorial is 2. Cancel 3 factorial here. 4, 5, 6 divided by 3 factorial is 2 times 3. The answer is 200. Ninth question. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? So totally 9 courses are available. Out of these 9 courses, 2 are compulsory. So we will group these 9 courses as compulsory and non-compulsory. And we have 2 compulsory courses. 9 minus 2, 7 non-compulsory courses. Totally 5 courses the student has to select. 2 are compulsory. So 5 minus 2, 3 remaining courses the student has to select from non-compulsory group. Therefore, number of ways. This is also only selection question, combination question. 2C2 and so multiply 7C3. 2C2 is 1. See, 2 factorial divided by 2 factorial becomes 1. This is 7 factorial divided by 3 factorial times 7 minus 3 is 4 factorial. This is 1 multiplied by, cancel 4 factorial, 5, 6, 7 divided by 3 factorial is 2 times 3. The answer is 35. So 35 combinations are there of selecting 5 courses, out of which 2 are compulsory. Example 17. If NC9 is equal to NC8, find NC17. So we cannot equate 9 and 8. Let us use NCR is equal to NCN minus R formula on any one side, either on the right side or on the left hand side. So NC9 is equal to, I am using the formula for NC8. So it becomes NCN minus 8. Now let us equate 9 and n minus 8. Therefore, n is equal to 9 plus 8, which is 17. But we have to find the value of NC17, which is 17C17. 17C17 is 1. See, 17 factorial divided by 17 factorial times 0 factorial, which is 1. Example 18. The committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? How many of these committees would consist of 1 man and 2 women? We have to select 3 persons out of 2 men and 3 women. In how many ways can this be done? Number of ways is equal to, totally we have 5 people, out of which we have to select 3. Only a selection question, so it is a combination question. 5C 3 ways, which is equal to 5 factorial divided by 3 factorial times 5 minus 3 is 2 factorial. Cancel 3 factorial. 4 times 5 divided by 2, 10. The second part of the question is, how many of these committees would consist of 1 man and 2 women? We have 2 men and 3 women, out of which we need to select 1 man and 2 women. Here we have and, so we need to multiply. Number of ways of selecting 1 man and 2 women. 2C1 and, so multiply 3C2. 2C1 is 2 and 3C2 is 3. Number of ways is 6. Out of 10 combinations, in 6 combinations we will have 1 man and 2 women. Example 19. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? So that is the first question. Number of ways of selecting 4 cards. Is equal to 52C4, which is 52 factorial divided by 4 factorial multiplied with 48 factorial. Cancel 48 factorial. 49, 50, 51 and 52 divided by 2 into 3 into 4. 13 times it goes, here it goes 17 times, this is 25. 49 into 25 is 1225 and this product is 270725. First subdivision. In how many of these 4 cards are of the same suit? Out of 52 cards of a pack, we have 4 different suits: hearts, diamonds, clubs and spades. And in each suit we have 13 cards. All 4 are of same suit, so we can select all 4 hearts or all 4 diamonds or all 4 clubs or all 4 spades. Therefore, number of ways of selecting 4 cards of the same suit is equal to 13C4. For OR we do addition. 13C4 plus 13C4 plus 13C4. Repeated addition is multiplication, so it becomes 4 times 13C4, which is 4 times 13 factorial divided by 4 factorial into 9 factorial. Cancel 9 factorial. 10, 11, 12, 13 divided by 4 factorial. 110 multiplied with 26. The answer is 2860. Second subdivision. In how many of these 4 cards belong to 4 different suits? We have 4 different suits: hearts, diamonds, clubs, and spade. And in each suit we have 13 cards. Four cards belong to 4 different suits. So we have to select one card of hearts, one of diamond, and one clubs, and one spade card. Therefore, number of ways is equal to 13C1, and so we need to multiply 13C1 into 13C1 into 13C1. 13C1 is 13. It becomes 13 power 4. Which is 169 into 169. The answer is 28561. Third subdivision. In how many of these are face cards? In a pack of 52 cards, we have 12 face cards. In each design, we have king, queen, jack. These are the face cards. So 4 into 3, 12. On face cards, 52 minus 12, 40. We have to select 4 face cards. Therefore, number of ways is equal to 12C4, which is 12 factorial divided by 4 factorial times 8 factorial. Forty-five times 11, which is 495. Fourth subdivision. 2 red cards and 2 black cards. So in a pack of 52, we have red cards 26, black cards 26. And we need 2 red cards and 2 black cards. Therefore, number of ways is equal to 26C2 and multiply 26C2. 26 factorial divided by 2 factorial times 24 factorial. 25 into 26 divided by 2. 625 times 169, which is equal to 10562 2, 5. Fifth subdivision. Cards are of the same color. We have 26 red cards and 26 black cards. They should be of same color. So either you select all 4 red cards or all 4 black cards. Therefore, number of ways is equal to 26 4 or for or we add 26C4. It is 2 times 26C4, which is 26 factorial by 4 factorial times 22 factorial. Cancel 22 factorial. 4 factorial is 2 into 3 into 4. 24 could be cancelled. 2 times 25 is 50 and 23 times 26 is 598. The answer is 29900.